Delaware Tech, Chem 100, Chem 110, Unit 1 continued, significant figures in calculations. There are very specific rules on determining how many significant figures your answer will have once you've multiplied or divided other numbers or added and subtracted other numbers to get that new answer. The rule with multiplying and dividing is that you will round your answer to the least number of significant figures that was present in any of your original component numbers. For example, 4,500, which has only 2 significant figures, divided by 12.61, which has 4 significant figures, will give you this answer off your calculator. Well, that's all well and good, but the problem is you now have to determine how many of these digits you can actually trust. That is, how many digits really are significant. You can't just write down the whole thing because you can't trust all of these digits. So the rule says, look at each of the component numbers, 4,500 and 12.61, and since you are dividing or multiplying these numbers, you look at the one that has the least number of significant figures, which is 4,500, which only has 2 significant figures. Therefore, you need to round your answer to 2 significant figures, or to the nearest 10 in this case. So since this number is 356.8, etc., we need to keep the 3, and the 5 in the tens position will be our last significant digit. We needed to round that number. Do we keep it rounded down at 5, or do we round it up to 6? Well, since it's followed by a 6, a high number, we would round the 5 up to a 6, and then replace the remaining digit with a 0, giving us 360. Now, adding and subtracting, the rule is a little more complicated, and if I read the rule to you, you're going to say, what? This doesn't make any sense. So I'll read the rule, and then we'll actually do an example, and you'll see it's not that hard. Find the measured number, that's the component number, one of the ones in the original number, one of the original numbers, whose last significant digit is in the least precise decimal place. Then round your answer to that decimal place. Well, that seems pretty confusing, so let's give an example. The example, 3.4 plus 4.56 plus 8.110. And these could have been pluses or minuses as long as it's some combination. But in this case, they're all pluses, and our answer off our calculator would say 16.070, or the calculator would probably leave off that last 0 entirely. But when you add these by hand, you'd see that this has 5 total digits, 16.070. Well, where do you round this number? Well, look at each of the component numbers. 3.4, the last significant digit is in the tenths place. 4.56, the last significant digit is in the hundredths place. And 8.110, that 0 is significant. Therefore, the last significant digit in that number is in the thousandths place. Well, we have one that's in the tenths, one that's in the hundredths, and one that's in the thousandths. The least precise of those would be the tenths place. Therefore, our answer must be rounded to the tenths place. In other words, our answer will be rounded to 16 point, and then that next digit will be our last digit. Since it starts with a 0, but it's followed by a 7, a large number, that 0 will be rounded up to a 1, and then we won't write any further digits. So 3.4 has the least precise last digit, tenths place. We round it to the tenths place, and we get 16.1 as our answer. Now, shown here are a lot of examples for you to practice, and I'm not going to go through every example, but I want you to note that on the left, these are multiplying and dividing, and on the right, these are adding and subtracting or combinations thereof. In each case, I've given you the answer that will come off of your calculator directly, but you have to provide the rounded answer. For example, 4.5 divided by 6.245, the first number has 2 SigFigs, the second number has 4 SigFigs, therefore we have to go with the less precise one of those, 2 SigFigs. So our answer of 0.72057,646, etc., would just simply be rounded to 0.72. Now, I can go through these, and what I'd like you to do is stop the video at this point, look at your PowerPoint presentation, and actually practice these to see if you get the same answers. Now, if we look at the adding and subtracting, here's an addition of 4.8 plus 6.8765. The first number, the last significant digit of the first number, is in the tens place, whereas the last significant digit in the second number is in the 10,000th place. Therefore, we will round to the tenths place, the less precise of those two, and therefore our answer will be rounded to 11.7. Now, I'll do one more here because this is a little bit tricky. 520 plus 94.98. Well, looking at the second number, 94.98, the last significant digit is the 8 in the hundredths place. But if we look at the 520, the last significant digit is not the 0, it is the 2. You'll notice there's no decimal point on the 520, therefore 520 only has 2 SigFigs, but its last SigFig is in the tens place. So we have to compare tens place versus hundredths place in the second number, therefore the tens place is where we need to round it. So our answer of 614.98 must be rounded to the nearest 10. So the question is, do we round it to 610 or 620? Well, since the digit after the 1 is a 4, we would round down, meaning we keep the 1 as is and fill in the remaining digit with a 0. And I'll leave these for you to do on your own. The answers are here, but you can stop the video before you go to that point and practice these on your own, or you can go to the PowerPoint presentation and do them one by hand.